All right, so I'm looking at number 7. Okay, so guys, like I said yesterday, the biggest problem with proofs is just son of a biscuit. So guys, the biggest problem with proofs is just figuring out where to start. All right, and again, there's no right answer. So, for example, if like this was on the test, I was grading your proof, I would be following along with each of your steps, trying to see if it makes sense. All right, because if it makes sense mathematically and logically, it's a valid proof. It may not have been the way that I solved it, but answers can vary. All right. So, if we look at number 7, given that triangle AB or ADB is congruent to triangle BCA, they want us to prove that DE is congruent to CE. All right. So, they already gave us our given. So, they said that triangle ADE is congruent to triangle BCE. Did I mark the right ones? No, BCA. Wrong thing. So they're saying that these two triangles are congruent. And they want us to prove that these two sides are congruent. All right. So the best way to do this is to show that ADE and BCE are congruent first. All right. That'll be the easiest way to approach this. So, first things first, whenever they tell you that two triangles are congruent, you go ahead and get any type of CTCs out of the way. All right. Because that'll help you with your proving process. So, where I would start are these two sides right here. Because we know for a fact that since those two sides are part of the big triangles, they gotta be congruent. So I would state that AD is congruent to BC. And that's by CPC TC. All right, so that's part of the two original congruent triangles, so they have to be congruent. All right. Now, where else do you think I can go? So that's the main CPCTC that I would mark. What else do you think I could mark? Right. So angle DEA or DEA. Yeah, DEA or CEB are congruent because they're vertical angles. All right. So we're saying angle DEA is congruent to angle CEB because vertical angles are congruent. All right. What's something else that I could say? So look at what we have proved now. So we have a side and an angle that's proven. So think about postulates. All right. what would make the most sense, or which postulate do you think we should shoot for proving the triangle with? So AAS, ASA, SSS, SAS. What do you think? I don't think SAS would work just because of the placement of the angle. All right, because the side's so far away from the angle, if we prove either one of these sides will have a butt. But it's a bad one for it. All right. Can't do SSA, spell it backwards. Don't want those congruency. AAS. All right. So what would you have to prove if it's AAS? Right. Angle D is congruent to angle C. What would the reason be? CPCTC. So these two angles right here are parts of the congruent triangles, our two original congruent triangles. So we can say that angle D is congruent to angle C because of CPCTC. So these two angles are congruent. Now we have angle, angle, side. So we can say that triangle ADE is congruent to triangle BCE by angle, angle, side. Now, since we proved that these two triangles are congruent, so we now have these two triangles that are congruent. All right. Since we proved that those two are congruent, we can now claim that DE is congruent to CE by CPCTC. So DE is congruent to CE by CPCTC. And we're done. So guys, like I said, with breaking these down, you may be wondering, why did I pick AD and BC to use my first CPCTC? Well, it wouldn't make sense to pick AB because it's not part of the two congruent triangles I need. We couldn't pick AE or EB because they're not part of the congruent triangles. All right. And if you do AC and then BD, you could prove it that way, but then you would have to go into a lot more steps and say, okay, segment addition, if you add these two segments, if these two are congruent, then blah, 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 blah. That's more going around the figure out. All right. So you kind of have to just think about it logically. So my suggestion is with ones like this, if they give you two congruent triangles, figure out which parts, because CPCTC, you can use to help prove two other triangles are congruent. Okay, does that kind of make sense? All right, any questions on that one? All right, so now sometimes I'll give you a proof, but I'll tell you the statements, and then you just got to give me the reason why that's true. Okay, so let's look at number 9. All right, number 9. If AD is congruent to AE and DB is congruent to EC, prove that angle B is congruent to angle C. So they already did the proof for us. They just didn't give us the reasons of why all the statements are true. So we're going to go through each of these statements and come up with a reason for it. Okay? So first things first, we have our givens. So let's just look. So they said that AD is congruent to AE. So these two are congruent. And then DB is congruent to EC. And that's just given. They then claim that AB is congruent to AC. So they're saying that AB is congruent to AC. Why do you think that's true? Guys, think logically. Look at what it's made up of. It's made up of two already proven congruent segments, right? So by segment addition, if you add two congruent segments, then that sum will be congruent, right? So this specifically, if you want to put a name to it, if you look at your green sheet from yesterday, all right, all right. So this would be, the reason is the sum of two corresponding congruent segments are congruent. All right, it's just addition. You could have also said a whole quantity is equal to the sum of its parts. All right. They then said that angle A is congruent to angle A. What's the reason for that? That's reflexive. They then say that triangle ABE is congruent to triangle ACD. So ABE, so this triangle right here, is congruent to ADC or ACD. All right, so they're saying that those two triangles are congruent. Why do you think that is? Which postulate makes that true? So we have a congruent angle here. This. So it's not angle side angle. It's not side side side. Side angle side. Good. So by side angle side, because I said that these two are congruent. Wait. Yeah. And then these little ones right here are congruent. So it's hard to see, but it is technically side angle side. This is by side angle side. Thus, angle B is congruent to angle C by CPCTC. So guys, once you prove that the triangles are congruent, whatever part that they need you to prove that's congruent, it's automatically CPCTC. Any questions on that one? All right, let's do another one where we're stating the reasons. And if they have one, let's do 8. All right. So given BD bisects angle ABC and AB is congruent to BC, they want us to prove that BD bisects angle ADC. All right. So firstly, they gave us that it was a bisector. So they're saying that BD bisects AB. So it's saying right here that it's a bisector. And it bisects this angle in particular. And then AB is congruent to BC. All right. So they first started by saying BD is congruent to BD. What property is that? Definitely reflexive. It's the same line. All right. They then said an angle ABD is congruent to angle CBD. So they're saying that this angle is congruent to this angle. Why is that true? Nope. It's a bisector. It's a definition of angle bisector. It cuts that angle in half. So definition of angle bisector. Now they're saying that triangle ABD is congruent to triangle CBD, and that's by side angle side. All right. All right. Then that means angle DBE, angle ADB is congruent to angle CDB. So they're saying that this angle is congruent to this angle. Why is that true? I heard it. Someone say it. We already proved the triangles are congruent, so the parts are congruent by CPCCC. I know it's a lot of C's. Now, since those two angles are congruent, that means that BD bisects ADC because why? Isn't that the definition of an angle bisector? So if a line makes two congruent angles, it cuts it in half. So this is also definition of an angle bisector. So guys, that's why knowing this vocabulary is really, really important. If you don't know what a bisector is, that proof would have been pretty hard. All right. Okay, any questions on that one? Do you guys want me to do one more proof together? Particularly hard one. All right. Let's try. Let's do 13. All right. So they're saying triangle AED is congruent to triangle BEC, and AC is congruent to BD. And they want us to prove that triangle ABD is congruent to BAC. So if I look right here, they just said that ADE is congruent to BCE. So these two triangles are congruent to each other. They also said that AC is congruent to BD. So these two lines in particular are congruent. So the goal is to prove that these big triangles are congruent. All right. So we're already partially there because we already have one side of the big triangles that are proven congruent. All right. So our next point of attack will probably be figuring out another side that's congruent or an angle that's congruent through the congruent triangles that they already told us are congruent. So where do you think you want to go with this one? So congruent triangles, so let's look at something we can say in CPCTC. They already told us that these two triangles are congruent. And I'm trying to prove these two big ones. I have one congruent side already. Right, side AD is congruent to side BC. And that's just because they're part of the congruent triangles, so CPCTC. So side AD is congruent to side BC by CPCTC. All right. Now, we have two sides that are congruent. So I can see two ways that we can prove congruency. All right. So we already have two sides are congruent. What's the only two postulates that we could possibly use to prove congruency? Side, 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 or side, angle, side. All right. Either one would work. I can tell you right now, either one of them, given the information we have, would work. You can prove it either way. Which way do you want to go for? Side, 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 or side, angle, side? Okay, let's say side, side, side. So that means we need to prove that AB is congruent to AB. Well, that's easy. What is it? So I can prove that AB is congruent to AB. Why can I prove it that way? What property? It's reflexive. Technically, those two triangles share that same side, so it's reflexive. Thus, I have enough information to prove that triangle ABD is congruent to triangle BAC by side, side, side. Now, if I wanted to prove it by side, angle, side, same number of steps. Let's say I switch these out. I know I'm kind of writing it over in 14, but we already did 14 for warm up. So, if I want to do side, angle, side, which angles would I have to prove is congruent? D and C. Can I prove that they're congruent? Yes. By what? CPCTC. So I could also have said that these two angles are congruent by CPCTC. So angle D is congruent to angle C by CPCTC. Thus, that would have made those triangles ABD congruent to triangle BAC by SAS. So guys, like I said, with proofs, there's more than one way to do them as long as you can justify the process that you're doing. All right. So both of those methods, we could have switched out the last two statements and gotten still proven the triangles congruent. All right. We just did it in different methods. Both of those would have been correct. If you gave me one of those on a test, it would be correct. All right. You guys feeling a little bit better with proofs? A little bit? Okay. So here's what we're going to do now. So for the rest of class, we're going to do a stations activity. All right. Now, you're going to be doing this with your groups, and they're posted around the room. Now, in your Delta Math packet, the very last page, I believe, is the worksheet for your stations activity. All right. Now, how this is going to work is I'm going to give you about 5 to 6 minutes per station. All right. Some of them are you're making a full out proof. Some of them are you're just stating what postulates are going on. It depends. All right. Now, if you want to use the whiteboards at each station, like the big ones, you can erase what's on there and use that for scratch work if you want to. All right. Work together with your group, but everyone needs to record their answers on that worksheet. All right. Okay. Any questions? So I want you guys to start at the station where you wrote your proof for the warm up. All right. So whatever board you were at, that's the station you're going to start at. All right. Now, if you get stuck, please raise your hand. I'll come help you.
Should I erase it?
Yes.
Should I erase this?
Yeah, I would. And then you can just pull that down so you can actually see it. So, guys, if you're at the ones with magnets, you can pull it down if you need to or move it wherever you need to. If you guys want to use a whiteboard, like one of the smaller ones for something hard to write on, you can do that as well.
I'm gonna pass this class from the hotel.
Number one, let me just say that because
This
he
is
is the
station
midpoint, these two are equal.
Wait, right, station 4. Okay, so there's
I don't have the last page marked like this. So I have like a copy.
Did it cut off again?
Obviously, just he's the midpoint. He is the midpoint. So it takes and then I don't know what triangle is to double
What are you guys getting? It's stuck.
And then what's number two? In this piece, show F.
wait, okay, so midpoint, so wait, so I'll erase this. These two have an anchor at these sides. And then there's an angle.
Remember this?
D, so this. So SA, no, ASA.
Just make sure you're erasing it. Catch your body.
I think that's you rotate. Does that sound right?
So do we go to 5? Sure.
No, we just go to one that's open.
Wait, so the triangle would be like SA.
All right, guys. Let's
Those
get
are
down.
no, those are equal
2
to
more
C.
minutes on this station.
Basically, put in parentheses. This is
We're going in order. So I'll tell you when to move.
I
So-
what is
You guys want to go ahead and start on that. Actually, you know what, guys? Go to the, if it's open, go to it. So the bench station, if it's open, go to it.
It's not like
Yeah, you can make sure that station's back on board. You just have to find So boys, are you guys go to that one over there?
that one.
Or you can go to two. So either this one or this one. Just there.
DMT is still working.
Sorry.
It's your team. I thought it was
Well, letter B, it may not be. Yes, that's it. You don't need to go over. I just had to know.
It's like what? It's 4. It's 4. Station.
We could put up there too.
Well, that's I guess so. Wait, or if it's like 14, like on this thing. I get one of them statements. It's like number one is the statements.
Well, this one is. This one's right. By the way, guys, just so you know, this is totally not like what you're currently doing, but Thursday is definitely going to be your test. So we're going to review tomorrow, test Thursday. It's not all. The software coach but I'm not sure because having maybe we can all get one. Fair enough. Oh yeah, my sophomores. If you're not gonna be here tomorrow for the field trip, just come see me after school tomorrow, and I'll give you your well, just come see me before you leave. Like, just get each of them. Or will you have it ready by tomorrow morning? Yes. I should. Yeah. Okay. So if I come here tomorrow morning. Yeah. I can get it. Yeah. I'm just gonna see if Tina will see. Okay. Oh yeah, I got that. If you're on stage today, just try your best. It's a challenge for a reason. Like, just try your best. Two's open and one's open. I've never learned. I don't understand. Guys, this one. This part. Also, guys, when you're doing proofs and flow proofs, help you a bit more. That's you can do a flow proof instead of a two column. The reason is just the posture. I think what's the statement? That's the same. That's like statement and reason. No. The statement is the two triangles are congruent, so you actually make the triangle say that. The reason is by the posture. I think I tell you
Only one that's same group.
Oh wait, oh wait, y'all. Here.
I conducted the study from Tucker Law. Yes. I love drawing.
Hey guys, been to
Here again.
I think we all went before.
The first one? Oh, he's.
Why are you on
Boys, we've been stationed. So same word five. Well, station's fine, but it's like on the board.
I like your
Have y'all done?
We've done that one. I'll let you
So your next is like
obviously he's been like, well, I'm trying to okay, this one is kind of well, that line has all these, I think, side.